Hello, my name is Matt Labosco, and today I will be talking about the famous Citigroup Center Tower located at 601 Lexington Avenue in Manhattan, New York. The topic of my presentation has to do with surprises that occur during the construction and construction administration process, so today I will be focusing on a structural engineering error that could have resulted in disaster had it not been caught. These are the contents of the presentation alongside a photo of the building and its iconic stilted construction. First, I will go through some quick facts about the building and its background, and then get into the engineering crisis that occurred. After that I will discuss how the design team was able to recover from this crisis, and actually improve the building design in the process. Here is a photo of the skyscraper and its equally iconic crown, which features a massive 45-degree slanted roof. The Citigroup Center is a 59-story office building located in Midtown Manhattan. The building is owned by Citicorp, now known as Citigroup, who hired the architecture firms Hugh Stubbins and Emery Roth and Sons to handle the design. Although the architects did an amazing job designing the tower, it was the work of the structural engineer, William Lemsurier, and his team, which make this building so iconic. The slanted roof stands at about 915 feet above ground level, which made it the seventh tallest building in the world at the time of its completion in 1977. The building is known for its extremely unique structural system, and its retail plaza, which is sunken 12 feet below grade and located directly under the tower. The tower itself is supported by the central core and four massive stilts measuring approximately 112 feet high, or about 9 stories. The Citigroup Center Tower was built on the site of the original St. Peter's Lutheran Church, built in 1862. When Citigroup proposed their project to the owners of the church, they agreed to sell their land on 2 conditions: 1, that Citigroup would build them a new place of worship, and 2, that the structural system would not interfere with the newly constructed church. Because the new church would be located directly under the skyscraper, Lemsurier had a problem to solve. So, instead of placing the building's strongest vertical supports at the corners of the building, like most typical skyscrapers, Lemsurier and his team places them at the midpoints of all 4 sides. And rather than distribute the weight outward to the perimeter of the building, the structural system uses a chevron-shaped pattern to transfer the loads inward. The chevron bracing structure made the building exceptionally lightweight compared to typical buildings of the same size, which would make the building sway in the wind. The structural system also includes a 400-ton tuned mass damper, which would keep the building stable in high winds and storm conditions. According to the sources I've read, this damper was the first of its kind. The design was regarded as ingenious and cutting edge. Now for the surprise. Construction on the building was coming along very smoothly and was actually near completion, until Lemsurier got a phone call from a Princeton engineering student by the name of Diane Hartley. Hartley warned that the building features a fatal design flaw which would cause the building to collapse under high winds. After the phone call, Lemsurier checked the student's calculations, and determined that she was correct. The engineering team had designed the building to withstand powerful perpendicular winds which act on the building's sides, but due to cost-cutting efforts by the development team, bolted connections at the building's corners were not sufficiently designed to withstand high quartering winds. Since the tuned mass damper was electrically supported, in the event of a blackout, it would not be able to transfer the high wind loads, and the building could collapse. Lemsurier calculated that a storm powerful enough to destroy the building could hit New York an average of once every 16 years, which was not a gamble that they were willing to make. After learning of the major design flaw, the Citigroup team rushed into action to coordinate emergency repairs. Before the team started any work, they devised an extensive evacuation plan which spanned a 10-block radius. Luckily, this plan never needed to be put into effect. In the middle of the night, the construction team examined the entire building and welded 2-inch steel plates over the building's 200 bolted connections. The public, and even the building's occupants, were never notified of the emergency repairs so as not to cause a panic. Amazingly, the repairs were completed by daybreak. After the repairs were complete, the engineering crisis had been solved, and the building stands today, exceeding its originally intended safety factor. In terms of the effect on project schedule, the repairs were completed after construction was complete, and the building was occupied. Also, the repairs were done extremely quickly, so there was virtually no effect on the construction timeline. On the other hand, the cost of repairs was a different story. Estimated total cost of repairs ranges from $6 to $8 million for structural work alone. Elie Messurier's insurance company agreed to cover $2 million, and Citigroup accepted this with no fault to Elie Messurier's firm. Although some might consider this a massive mistake on Elie Messurier's part, the firm acted immediately, appropriately, and efficiently. Surprisingly, the ordeal actually boosted Elie Messurier's career as a competent structural engineer, and the iconic spirit of the building lives on.